Okay, Bella, so today we're going to be looking a lot at scatter plots and using them to write equations in slope-intercept form. You've probably seen a scatter plot before. I think Mr. Bound teaches them to you guys. And it's basically this. It's a graph in the coordinate plane, usually just the first quadrant, and it's based on data. So you can see there's a linear relationship, right? They sort of follow a trend. It's not a perfect straight line, but if I wanted to, I could sort of draw a straight line through most of the dots. So it's very closely related to a function. So this right here shows a positive relationship because this is showing wages. So the amount you earn at your job in wages, increases with the number of hours that you work. So whenever two variables increase together or decrease together, that's called a positive relationship. Because if I were to draw this line, right? If I were to just sort of start at the origin here and draw this line, you can see that the line has positive slope. So if it has positive slope, it's a positive correlation. Negative slope would just be the opposite, right? It would be a negative correlation. And no correlation is just sometimes what you see when there's just random dots scattered around. So if the data shows no trend, it has no correlation. For this video, though, I want to keep this really short. This is one example we're going to look at today. This shows a population of zebra mussels, sort of an invasive species here, and looks like a biologist or someone charted their population growth over a certain period of time. Now, this is represented both in the scatter plot as well as in this table. And I want us to write an equation in slope-intercept form for this line of best fit. This is what you call, when you draw a line on a scatter plot, it's called a line of best fit. Now, the easiest way to do this is, because it's hard to tell where this line hits various points on the graph, you're much better off just using the data in the table. Now you can see here, these are our x values here, right? X is a time value, and it's years since 2009. So our domain is 1, 2, 3, 4, 5, 6, 7. And then these values here, they number in the thousands. These are our range values, right? This is the number of mussels growing over X number of years. Now, in order to get the most accurate read, because there is not one single slope value here, these points they're not on a perfectly straight line, so you're not going to get the same slope every time you do this. But the most accurate is to take the first point and compare it to the last point. So in other words, we want to use the ordered pairs 115 and 7, 483. That's going to give us the best, because that's the longest span in time. If we only use 2 points that are real close together, that may not give us a very representative value. So anyway, let's find the slope here, a change in y over change in x. You know the drill. So my change in y, right, keep careful, y is on the bottom this time, from 15 to 483. So you really just subtract that, right? Well, I'll grab my calculator here. So if I do, 483 minus 15, it's going to give us 468. So that's my change in y, is positive 468. Again, we can see this slope is going to be positive because it's a positive trend. And we're dividing that, well, from 1 to 7 is 6 years. So this is 468,000 mussels over a period of 6 years. And when we divide that, so divide by 6, we get exactly 78. So our slope is 78. Right? So we have, once again, y equals mx plus b. Y, the number of mussels, is equal to 78 times x plus b. But now we have to find out what our y-intercept is, because you can't really tell from this graph here. I can see it's going to be below 0, but I don't know what that is exactly. So just like we did last week, we choose any ordered pair you want, plug in the x and y value, and then we solve for b. I would just use the first one. It's the easiest because the numbers are the smallest. So let's use where x is 1 and y is 15. So I'll put 15 equals 78 times 1 plus b. So really we're just going to be subtracting 78 from both sides. That's going to give us b equals negative 63, I think. Negative 63. So our final answer for this, for the equation, I'll write this in a different color here, is just going to be y equals 78x minus 63. 63. Translation would be it has a y-intercept of negative 63, and since 2009, the year they started gathering data, the population of zebra mussels increases at about 78,000 mussels per year. So what you really care about is making sure that you can use a table like this, use the extremes, like 1 and 7, use the bookend values to calculate your slope, and then use any ordered pair to approximate the y-intercept. And we'll do plenty more with this today when we meet.